Okay, I'm going to continue here, logarithmic in exponential equations, and it's going to be part 2, which is starting from question number 13. But before I start solving, I would like to load up here the properties that possibly we will use it. And that is going to be logarithm A plus logarithm B is equal logarithm AB. Remember, we have to have the same base. In this case, we have base 10. One thing is crucially important to know, so it's gonna go both ways, interchangeable, which means addition you can convert into multiplication, multiplication you can convert into addition. Same thing is with subtraction. B, it goes both ways. It's going to be log A divided by B. Third one, it's going to be power. So power log A, it can be equal both ways again. Log A to power P. And the last thing also, I would like to write down how to represent the format of representing logarithmic in the form of exponent. So if we have log A by base C is equal B, then let me take a little bit more space so we can fit in. Then we can write down that C to power B is equal A. How we do that? We take this base raised to power B, it's equal A. Okay, so far that's all we need. If I forgot something, I will add as we go. So question number 13. We have 4 natural log 2x is equal 20. How are we going to solve this type of problem? In my previous case, I told you that if on one side you have logarithm, on the other side you don't have logarithm, then the best way, method to apply is this method, this one. And that is still valid. With the difference here, I want to get rid of coefficient of 4 to make it easier. So because here I have 4, on the right side I have 20, I can divide both of them by 4. So that's going to be 4 natural log to x is equal 20. And we divide by 4 this, divide by 4 here also, because whatever change you do to one side of equation, you have to do precisely same change to the other side, the side of equation. This is 1, this is 5. So we have natural log 2x is equal 5. Now we can apply this method, use the exponential format expression. So it's going to be e, because our base is e to power 5. And let me write down here e, so that every time when you have natural log, we understand e. So e to power 5 is equal to x. How much will be x from here? Well, we need to get x, we need to get divide by 2, right? So this is gone. And our x is equal e to power 5 divided by 2. Okay, so to get the precise result, you want to get how much it's going to be, e to power 5. I have here e. I'm using this time my calculator in the computer, or you can use your iPhone or any calculator you have. Let me find x to power y here, 5, and I am getting 148.4 and divided by 2. And I'm getting 74.21. Okay, this is the result I got. So it's based on requirement. If your problem won't asking the precise value, then you can get precise value. If not, e to power 5 over 2, it's going to be your solution. We use curly braces when we have specific number or value as an answer. We use parentheses when we have coordinate or when we have interval. Question number 14. We have log x plus 7 by base 3 is plus log x plus 5 by base 3, and that is equal 1. Okay, let's solve this one. How are we gonna solve this case? We are going to apply the property of addition, which is this one. Let me mark down as 1, 2, 3, 4. It will be easier. I'll write down here. We are applying formula, property for 1. Okay. I can drag this down also as we go. I will drag this down so we will have it in front of us. Okay, we are applying first one, which is addition convert to multiplication, and it's going to be log by base 3 x plus 7 times x plus 5, and that is equal 1. Okay, so from here, what we can do, again, when on the one side we have logarithm, on the other side we don't have logarithm, we are using the presentation number 4. Let me move this a little bit on the side. It's getting too close to there, much better. So number 4, we are using number 4 statement, which is going to be 3 to power 1 is equal x plus 7 times x plus 5. Okay, so, well, let's distribute. 3 is equal x times x, x squared. X times 5 is 5x. Next, 7 times x, it's going to be 7x. No, I don't want this color. Let me take this one. It's going to be 7x. And plus 7 times 5, it's going to be 35. So combining like terms, we get x squared plus 12x plus 35. So we are getting quadratic equation, right? Let's move this 3 also on this side. It's going to be minus 3 and will be left only 0. So 35, we get x squared plus 12x and then plus 32, right? Equals 0, combining these two. All right, so what are two numbers that multiplication will give me 32, addition 12? It's going to be x plus 8 and it's going to be x plus 4 is equal 0. All right, for this case, we have x plus 8 is equal 0, x is equal negative 8, x plus 4 is equal 0, x is equal negative 4. Every time when we get negative number, we have to be careful and we need to check it. So we won't get negative number under logarithm. Okay, so we will not get negative number under logarithm. Therefore, what we're gonna do, if I take this negative 8 and plug into original problem, like here, negative 8 and negative 8, we are getting the log negative 1 by base 3 plus log negative 3 by base 3, which cannot happen. Therefore, we are going to have negative solution in a negative value under log, and negative 8 cannot be considered as a solution. So if we take negative 4, let's check it. So we have log negative 4. Okay, plug negative 4 this color so you can see. Negative 4 plus 7 by base 3, and then plus log negative 4 plus 5 is equal 1. So what do we get as a result? So we get log log 3 by base 3 plus log 1 by base 3 is equal 1. So log 3 by base 3 is equal 1, because 3 to power 1 is equal 3. And every time, remember what I said, when we have log 1, that means exponent is going to be 0, period. Because any number to power 0 is 1, which is true. Big check mark. So therefore, x is equal negative 4 is going to be our solution. So that was question number 14. Moving to question number 15. Logarithm 5x minus 5 equal logarithm x plus 1 plus logarithm 6. So we don't have here written any base, which means our base is going to be 10. Okay? All right. So how are we gonna solve this problem? So we are going to apply the property again. Let me move it down. There we go. So we will have the property right here. I'm going to apply first property. So it's going to be log 5x minus 5 equal log x plus 1 times 6, right? Addition we convert into multiplication. Yes? All right. So from here, what we gonna do from here? Let me multiply. Let me put here a square bracket. So logarithm. Okay, from here, what do we have? We have log, same base of log on both sides, and based on the statement that if log m by base a is equal log n by base a, which is our case, base is the same and same log, then we can insist that m is equal n. This symbol meaning, let me Squeeze a little bit. So hence, this means hence, m is equal n. Okay, which means if you have the same log on both sides, you can drop this log and have the expression under the logarithm equal to each other. So from here, 5x minus 5 is equal 6 times x plus 1. Okay, 5x minus 5 is equal 6x plus 6. Okay, let me move 5x on this side. I don't want to get x negative. If I move 6x, it's going to be negative and I'm going to prevail, right? And 6 move on this side. So I will get negative 5 minus 6 equals 6x minus 5. Remind you, every time you move any term over equal sign, you just flip the sign onto opposite. You are getting negative 11 is equal positive x. So negative 11 is going to be our answer, but we need to check it if it's going to be satisfying as a solution to solution. Therefore, let's plug it negative 11. If I take this negative 11 plug here and negative 11 plug here, I'm going to get negative number under logarithm, which means negative 11, it's going to be rejected, which means we will not have solution for this problem. Or they put this is no solution, meaning this way. Okay. Moving to question number 16. Let me move this down. Well, it's nearby, we can scroll if we need to. We have 2 logarithm x minus logarithm 5 is equal logarithm 80. Okay, so how are we gonna solve this problem? Again, we have logarithm everywhere, therefore I'm going to apply the properties of logarithm, and the property is going to be second one, subtraction converting into division. All right, applying second one, which is going to be, oh, I have 2 log. Okay, let's first apply property free, take care of exponent, which means going to be log x squared, right? This 2 coming back here as exponent, minus, that's based on property free, minus log 5 is equal log 80. And then it's subtraction. I'm going to convert into division. Log x squared over 5 is equal log 80. All right. So from here, since we have log on both sides, based on number 5 statement, if we have log and log, same base, and we do have, our base is 10, then we can drop this log and have x squared over 5 is equal 80, right? So from here, x squared is going to be equal 80 times 5. How I got that? Very easy. We bring to common denominator. What is common denominator? 5. That's mean here it's going to be 5 and multiply 5 also, right? And then we drop this 5. X squared equal 80 times 5. And from here, x squared equal 400. right? And x is going to be equal plus minus 20. So recall that any number that produces the logarithm of a negative number or the logarithm of 0, because there is no exponent on the earth that you raise power and will give you 0. There is no such thing. So therefore, a logarithm of negative number or logarithm of 0 must be rejected. So let's check what we're gonna get. So if I take negative 20, that's it. I'm plugging here negative 20 and it already will be rejected. So negative 20 is gone. So x cannot be equal negative 20. And we are going to check positive 20. Check twice. Logarithm 20 minus logarithm 5 is equal logarithm 80. Okay, so let's get to the bottom of this. This is going to be logarithm 20 to power 2 minus logarithm 5 equal logarithm 80. And we get logarithm 20 squared is going to be 400, right? Divided by 5, because subtraction converted into division, equal logarithm 80. Okay, we have same log on both sides. We drop. And 400 by 5, it's 400 over 5 equal 80, which indeed 400 divided by 5 is 80, equal 80. So x is equal 5. X is equal 20. It's going to be our solution. All right. Moving to question number 17. All right. What do we have for question number 17? We have number 17, natural log x minus 4 plus natural log x plus 1. It's equal natural log x minus 8. Looks like we have all around natural log, so which means we will apply property and then drop log, natural log. All right, so natural log x minus 4 times x plus 1, right, is equal natural log x minus 8. So from here, log and log, we can drop it, and we get x minus 4 times x plus 1 is equal x minus 8. All right, well, let's distribute. This is going to be x squared. This is going to be plus x. Next, this is going to be minus 4x. This is going to be minus 4. And that is equal x minus 8. So looks like this x and this x are going to cancel because they are on different sides of equal sign. So once you transfer one of these x's on one side, you are going to get negative and it will cancel each other. So therefore, it's going to be, we are going to get a quadratic equation. So therefore, we write down x squared minus 4x minus x and plus 8. I moved 8 equals 0. So from here, x squared minus 4x and plus 4, right, equals 0. So what is going to be the solution here? x minus 2 times x minus 2, we are factoring, or we can use perfect square. We can use perfect square, a squared, it's going to be perfect square, which is a minus b squared is equal a squared minus 2ab plus b squared. So if my a is let me represent x x squared is going to be my x squared. Hold on, then let me go this way to make it easy. Minus twice a. If a squared is x squared, then a is going to be x, yes? Okay, this is 2, this is, and b, it's going to be what? Since the 4 is our b squared, let me write over a squared minus 2ab plus b squared. If 4 is our b squared, then b is going to be 2, right? So I'm doing times 2. And plus b squared is going to be 4, right? Does it match? Do we get here x squared minus 4x plus 4? Precisely what we have here. Yes? Therefore, based on perfect square, we can say that we have x minus 2 squared. Same way like here we have x minus 2, x minus 2. It's the same way, x minus 2 squared equals 0. From here, x minus 2 is equal 0, x is equal positive 2. Okay, we have positive, but because under the natural logarithm here, I have x minus 2. Let me take this one. I have x minus 2. So, therefore, it's going to turn into negative 2, right, if I plug 2. Therefore, this problem has no solution. Or you just choose, on my MATLAB, it says there is no solution. Just choose no solution instead of this format. Okay, moving to question number 18. What do we have? Question number 18. Natural log x minus 3 minus natural log x plus 4 is equal natural log x minus 2 minus natural log x plus 9. All right. So what do we have here? On the left side, we have division, right? Because it's subtraction. So we get x minus 3 over x plus 4. On the right side, we also have division, which is going to be natural log x minus 2 over x plus 9. Since on both sides we have natural log, we are going to drop it. And we will get x minus 3 over x plus 4 equal x minus 2 over x plus 9. So we have here rational equation. Okay, so I will place the reference to the video how to solve problems with the rational equations. But in here also we will solve it. So x plus 4 and x plus 9, they don't have anything in common, which means denominator is going to be x plus 4 times x plus 9. Which means on this side, I'm going to add here x plus 9. Here also x plus 9. And on this side, I'm going to add x plus 4. There we go. So we got the common denominator everywhere. So we have on the left side common denominator x plus 9, x plus 4. On the right side, common denominator is x plus 9, x plus 4. Since they are identical, what am I going? Throwing it out the window. We don't need that. Which means, why? Because if the bottom is equal, if I have x, let me see, x over 3 is equal 2 over 3. If denominators are the same, equal 3, then to validate this equal sign, x has to be equal 2, right? If x is anything but 2, then it's not going to be equal sign. If I have 4 over 7 equal x over 7, then x has to be 4, right? To validate equal sign. If I have 4 over 7 equal x over 6, you cannot drop denominator and have x is equal 4. But when denominator is the same, you can drop it and have numerators equal. You can drop it and you have numerators equal. The same way we have on both sides same denominator, I'm dropping, and I'm going to have x plus 9 times x minus 3 is equal x minus 2 times x plus 4. Okay, let me make this drafting is gone, not to make it messy. Okay, let's solve it. So I will have x times x. It's going to be x squared. X times negative 3, it's going to be negative 3x. And then I will have 9 times x. It's going to be plus 9x. 9 times negative 3, it's going to be negative 27. And that is going to be equal x times x. Here I have x squared. X times 4, it's going to be plus 4x. And negative 2 times x is going to be negative 2x. And negative 2 times 4, it's going to be negative 8. So what do we have? On both sides, I have x squared, which means I can cancel. Because if I move one of them, it's going to flip the sign and will be x squared minus x squared, right? So therefore, when on the opposite sides, on the left and right side, if I have the same term, so I can cancel without moving them around. So different story with the rest. So here I have 3x minus negative 3x plus 9x. It's going to be 6x minus 27 equal 4x minus 2x is 2x minus 8. Okay, so from here I am moving 2x on this side and 27 moving on this side. And we are going to get 6x minus 2x because we are moving, so we flip the sign. And 27 was negative, will become positive, minus 8. All right. So we get 4x is equal 19. And x is equal 19 over 4. So 19 over 4 is, how much is it approximately? It's not approximately, precisely we can find out. It's a 4 and 3/4. How did I get? I divide 19 over 4. This is also another video I can place there, how to convert improper fraction into mixed fraction if somebody is interested. 19 divided by 4. It's going to be 4 times, right? That's a whole number. And 4 times 4, 16. Remainder is 3. This remainder comes to numerator, 3 over 4. Okay? That's how I got. Otherwise, I will put the reference I promised two reference, right? One is to converting improper fraction to mixed fraction. The other one is solving equations with rational expressions. Okay, so let's which is 4 and 3/4. So if I plug here 4 and 3/4, I can plug it easily because we are getting positive number. 4 is greater than 3. Well, here is addition, so nothing will happen. This x plus 4. Here also 4 and 3/4. Also, it's going to be positive, and here is addition. So yes, I can accept it as a solution, which means x is equal 19/4. It's going to be the answer. Question number 19. So we have natural log my handwriting is horrible, sorry. So natural log x minus 2 minus natural log x plus 7 is equal natural log x minus 1 and minus natural log x plus 10. Okay, so again we are going to use properties. The subtraction convert into division. I thought, yeah, that was 18. Okay, x plus 7, I thought I'm repeating 19, equal natural log x minus 1 over x plus 10. Okay, so we can drop this natural log. We get x minus 2 over x plus 7 equal x minus 1 over x plus 10. So x plus 7, x plus 10, they don't have anything in common, which means we need to multiply one by another. So what am I doing here? I'm going to take in parentheses this, and I'm going to multiply this one by x plus 10. And because whatever change we do to denominator, we have to do to numerator also. And here will be x plus 7. Here also x plus 7. We have the same denominator, and I explained to you when denominators are equal, the numerator also have to be equal, which means I can drop this denominator, throw it out a window with big pleasure. I'm pretty sure you will do that. So this is going to be x plus 10 times x minus 2 is equal x minus 1 times x plus 7. All right, let's go. X times x, x squared, x times negative 2 minus 2x. Now 10 times x is plus 10x. 10 times negative 2 is negative 20. This is equal x times x is x squared. X times 7 is 7x. Negative 1 times 7 is negative x. Negative 1 times positive 7, negative 7. Again, x squared is gone. Do we have here anything else? Not so far. So we are getting to negative 2x plus 10x. It's going to be 8x minus 20. This is equal 7x minus x. It's going to be 6x minus 7. So from here, 8x minus 6x is equal positive 20 minus 7. So 2x is equal 13, and x is equal 13 over 2. Although we have positive number, but let me see if we have subtraction. We have subtraction, so let's check it. 13 over 2 is 6 1/2. And like I said, I will put the reference how to convert to mixed fraction. So if I plug here 6 1/2, I'm going to get positive. Here also I'm going to get positive. Where we have plus, we have nothing to worry. We will get positive anyway. All right. So we are safe. We can accept it as a solution. So from here, 13 over 2, it's going to be solution. This was question number 19. Moving to question number 20. Question number 20, log x plus 3 by base 4 is equal 2. All right. In this case, since we have log on one side and we don't have log on the other side, then what we're gonna use, remember what I said? We are using the form of exponents. Where is it? Here it is. Let me move it down. Okay, we are almost there. Here we are. So we are going to use the form number 4. Number 4. Every time when you have log on one side only, then that's the method you're gonna use, which means 4 to power 2 is equal x plus 3. From here, 16 is equal x plus 3. And moving 3 on this side, x is equal 13. So 13 is our answer. Okay, there is nothing to check because we have addition and the result is positive anyway. So we are good. Next one. Number 21. We have log x minus 2 by base. No, let me see. X plus 24 by base 2 is equal 3. All right. So again, log on one side, therefore we are using the form 4, where we can take the base raised to power, which is 3 in this case, and get x plus 24. 2 to power 3 is 8, equal x plus 24. And moving 24 on this side, it's going to be negative 16 is equal x. X is equal negative 16. Oops, now we got negative answer. So we need to check. Therefore, if I plug negative 16, well, it's a safe because we get positive answer. Therefore, we can accept negative 16 as a solution. We are safe. Okay. Question number 22. Seven natural log 2x is equal 28. Right? I believe we solved similar in the beginning or something, but that doesn't hurt. So first of all, every time when we have here coefficient, I want to get rid of it because I can divide 28 by 7, right? So I'm going to divide by 7 here, divide by 7 here. This 7 is gone here, this is 1 and 4. Therefore, I'm getting natural log. Okay, you know what? I didn't want to write on original problem. Let me rewrite here. 7 natural log 2x is equal 28. Okay, let it be. So we get natural log 2x is equal 4. So from here, e to power 4 is equal to x, right? So to get x, we divide by 2, divide by 2. This is gone, and our x is equal e to power 4 over 2. If somebody needs precise value, you just plug to calculator e to power 4 and divide by 2, and that should be approximately 27.3. Okay, question number 23. So logarithm x by base 9 plus logarithm 8x minus 1, and that is equal 1. So on the left side, okay, base 9, we have addition, which I'm going to convert into multiplication using property. So log x times x 8x minus 1 by base 9 is equal 1. Okay, so I'm applying the method of writing logarithm in the format of exponents. 9 to power 1 is equal x times 8x minus 1, right? We have log on only one side. So from here, 9 is equal 8x squared minus x. So we are getting quadratic equation, 8x squared minus x minus 9, right? It's going to be equal 0. Okay, in this case, it's going to be, we are going to use a method of discriminant because we cannot factor it down. And I'll put also the video. So I have to put a method of the factoring, foiling based on discriminant. I mean, no, this time we are going to solve equation based on discriminant. Then I have to put the how to solve exponential, not exponential, equations with rational exponents. And foiling also, right? These 3 topics I will post at the end of the video. So I'm going to use now this method of discriminant, which is ax squared plus bx plus c is equal 0. So in my case, let me write down ax squared plus bx plus c equals 0. In my case, my a is equal 8, b is equal negative 1, c is equal negative 9. Okay, so, and once we have it, my solution is going to be x1, 2, because we are going to have 2 x's as a solution, negative b plus minus b squared minus 4ac over 2a. So let's go here. x1, 2. Let me rewrite nicely. we have negative b. My b is negative 1. So negative b is going to be positive 1, yes? Okay, positive 1 plus minus b squared, which is going to be 1, minus 4 times a, and then times negative 9c, and divided by 2 times a, which is 8. So I applied this formula. So what do we get from here? x12 is equal 1 plus minus, so we have 1 minus 4 times 8 is 32. Yes, and 32 times 9, let me do it. 9 times 2, 18, 1 in mind. 9 times 3, 27, and 1, 28. Negative 288 over 16. So x1 and 2, it's going to be equal 1 plus minus 1 plus 288, right, over 16. Let me see how much it's going to be. Square root of 289. 289 square root, it's going to be 17. So this is going to be equal 1 plus minus 17, because square root 289, it's going to be 17 over 16. So x1 is equal 1 plus 17 over 16. x2 is equal 1 minus 17 over 16. So here we get 18 over 16, right? How much we can reduce? Well, we can reduce by 2. It's going to be, this is question number 3, yeah. It's going to be 9 over 8, right? And this one is going to be negative 16 over 16, which is going to be negative 1. Let's check negative number and positive 1. Where is our original one? We have negative 1 coming back here, negative 1. So looks like negative 1 is not going to work because I plug here, it's negative 1. This one also going to be negative 1. So it's not going to work, negative 1. On the other hand, 9 over 8, right? 9 over 8 is 1 and 1/8. 1 and 1/8. So let's see, if I come back here, here is my 1 and 1/8, it's positive. That's good. This is also 1 and 1/8 positive, so minus 1, we get positive. So which means 9 over 8 we can accept as a solution. I would put in the format of the mixed fraction, but all textbooks are accepting the improper fraction. I don't know what's the reason. Ask me easier question. Because when you go to the store, you are not telling them, give me 9 over 2 pounds of cheese, right? You are asking 1.5 or whatever. Normal mixed fractions we use in life. You are not telling in the store, Home Depot, and say, measure me 45 over 3 feet of carpet. We use mixed fraction normally, but all textbooks are going with improper fraction, unfortunately. So I'm going with improper fraction. And lastly, question number 24, the last question. We have log x plus 7 by base 5 plus log x plus 3 by base 5, and that is equal 1. Okay, on the left side we have addition that we can convert into multiplication. Log by base 5 x plus 7 times x plus 3, and that is equal 1. which means we are going to do 5 to power 1. Remember, we have log on one side, we don't have log on the other side. X plus 7 times x plus 3. And that is equal, 5 is equal, x squared plus 3x plus 7x and plus 21. Okay, so it's going to be 5 equal x squared plus 10x plus 21. Okay, so to solve it, quadratic equation, x squared plus 10x plus 21 minus 5 is equal 0. X squared plus 10x plus 16 equal 0. So if we FOIL it, x plus 8, x plus 2, and again I will have video reference at the end for this foiling, and x is equal negative 8, x is equal negative 2. Let's check it. Where is my original problem? It's right here. Negative 8, I cannot consider negative 8. I'm dropping right away because it's getting negative 1. So right there. And the second one also would get negative. But negative 2, that's fine. It's going to give me positive here. Give me positive here, positive here. So I can keep negative 2. So negative 8 is not going to be accepted. But x is equal negative 2. It's going to be our solution. Okay, thanks you for watching. Well, I hope you enjoyed and more definitely you learned, because that was the goal, to help you to understand exponential and logarithmic equation solutions. Thank you for watching.